So new assembly table, MFT table, router table, downdraft table, all in one. Let's jump in and do it. Okay guys, this is future me. So the MFT table is finished. Now, I used the UJK Parf guide System MK2 to make this top, but I ran into some issues with this system, a little bit discrepancies, so I had to solve some problems. So this video turned out to be a different video than I had intended to make. So in this video, we're focusing on the frame and the MFT top. Then I demonstrate how to use the UJK Parf guide system, plus fixing the errors that I got with this system. So that's what this video ended up being. Now, so with that said, here's past me who has no idea that he's going to run into problems. What's happening everyone? Welcome back to the workshop. Now in this video, like I said, I'm going to build a new assembly table. It's going to be an MFT top. I want to incorporate a router table into it and a downdraft table and storage area. Now, it's not all going to take place in this video. In this video, we're going to focus on making the frame and the MFT top, and then we're going to add to it in upcoming videos. We're going to add the router section. I'll explain all that later on. But for now, we're going to build the frame and the MFT top. So that's what we're going to focus on in this video. Now, why am I building it? Well, I want to clear up this end of the shop. I have a small assembly table here which is going to go. Its kind of top is not flat on it anymore, so I want to clear up a bit of space. I want to get rid of that. My router table, which is over here, it's kind of in the corner now, and it's not a great place to have it. So I want to keep that out in the middle of the floor on my new assembly table, which I'm also going to add wheels in a later video to this assembly table too. So that'll be in an upcoming video. So that's the reason why I'm building it. I want to actually create space in my shop by building an assembly table with storage area in it that will incorporate both that router table, get rid of this table, and it should free up some nice space in the shop. So let's look at the design and what we're going to do. We're going to keep it nice and simple and as cost effective as possible. Okay, so this is the area of the shop where the table is going to go. Now, the design of this table, like I said, I want to keep it nice and simple and cost effective. So we're going to be using an MDF top. It's a 25mm or 1-inch thick top. It's moisture resistant MDF. MDF is great stuff because it's extremely stable, comes extremely flat, nice and smooth, and it is almost perfectly dimensioned. So it's a great material to use, and the 1-inch top is good and solid. Now, it's also not that expensive. So when you're using an MFT top, you might actually cut into your top. It can be a sacrificial top as well, so it's easy to replace. It's not a big problem, and it's moisture resistant because my workshop is not insulated, and you can get a little bit of damp air in here over the winter months. So having a moisture resistant top is the way to go, so we don't get any mold or peeling or cracking or warping in the top. MFT or MDF is a good stable material so long as you don't get it wet, and the moisture resistant stuff is resistant to moisture and mold, so that's why we're using that. Now we're also going to be using 2x4 or 4x2 construction lumber. So the method we're going to use is exactly the same as my miter saw station. Now you will have seen me in previous videos build this exact design of workbench. I used it in my storage rack, I used it in the planters that I built, and I used it in the miter saw station. So I'm not going to go super in depth into this again. There's a full build of me assembling this style of workbench. The reason I use it, it's very, very cheap to build. It's extremely strong. It's modular. You can make it to any size you want. It goes up really, really quickly. Like I say, it's extremely strong and cost effective, and it makes a great workbench with plenty of storage, and you can always add to it, take away from it. It's very, very easy to chop and change it. It's very easy to replace the top when it needs to. You can replace the sides whenever you need to if they get damaged. So that's why it's a really good design in my opinion. So that's what we're going to be doing. So I'm going to crack on and get everything all cut up now. I'll assemble the bench itself and I'll take you through it. For everybody else who's already subscribed to this channel, you will have seen me do this, so I won't bore you with that. But for anybody that's new here, I'll take you through the table, and I suggest you go back and watch my miter saw station build. That will give you an in-depth into why we use this frame, or why I like to use this frame. So let's crack on and get the frame assembled. Okay, so we have our 4 end stretchers cut, so just have them sat in place here and here. So now we can measure between them for our long stretchers. It's important we do it this way. I'll show you why now. Okay, now I know I said I wasn't going to get super in-depth into this because you always see me doing it, but I'll just explain this again because it's worth explaining. So the reason why we orientate our legs in this direction and put this piece in first. So the short side piece goes in first. That means you have plenty to screw through here, and we also have plenty to screw through here, if you can see what I'm saying. So that's in 2 inches and this is in 2 inches. So both of them are caught an equal amount. However, if you were to put this guy in first, you can see you have about 10 mil there now, just under half an inch to catch a board that you put this way. So that's no good. It's not a very strong joint. I have made that mistake before, so just let you guys know not to make that mistake. To make sure you put in your short side pieces first and then the long side pieces so that it is held internally within the leg, if that makes sense. Okay guys, there we go. That's the frame more or less assembled now. I've added 4 more legs. That may not be the final position of these legs. I'm just putting one screw in them for now. This could change as this table evolves. Like I said, we're not going to complete this table today. We're going to get the MFT portion of this done today, and we'll be adding to it after that. So I've put in cross pieces for my bottom shelf. Now I'm using up all the offcuts. So these are side by side. So I just used some clamps to make sure that my distance is equal and everything is kept square. Because like I say, these are 2 pieces, not a single piece, but I'm using up the offcuts. And that will be underneath my bottom shelf. So this is ready to be flipped over now. So let's get on and do it. Okay, so now that we're flipped over, I want to slide the top on. Now I haven't put any cross pieces in the top yet, and there's a reason for that. I'm going to drill this out for my MFT table holes. I'm not exactly sure where the holes are going to line up, so I need to keep my cross pieces out of my holes. It'll all make sense now in a minute. So we're going to get the top on, and I want to build a frame around my top. I'm not going to fix the top down yet because I want to be able to remove it for the rest of this build, so it won't be fixed in place yet. But what we will do is just slide it on and get it in place. Okay guys, now that our top is on, like I said, it's not fixed in place and our cross pieces aren't in because I want to drill out our holes first, and that will tell me where I can put my cross pieces. Now I just want to get the edge banding on, so I'm going to use some 4x2s exactly like I did with the miter saw station to protect the edges. It gives it a nice border, a nice replaceable border that you can use and abuse, and it's easy to replace, like I say. So I've just cut all these to the right length. They're the exact size of my MDF board, 45 on the edges, and we're going to screw that on. Now, 2x4 is round all over, which means all the corners are rounded off, which means you don't get an exact perfect joint between the board, which has a perfect straight edge, and the 4x2. Now, it is very minute, very, very small issue. It hasn't caused me any problems on my miter saw station, and as long as the board 2x4 is perfectly flush with this top as it needs to be, then there's no real issues. You could run this through your planer if you wanted, but you know, 4x2 construction lumber is full of knots, so I'm not going to do that. Or you could run a track saw down it and square off that edge and match it perfectly. But again, it's so minute, it's not really, it's only a small detail and it's not really needed. And like I say, this thing is built to be used and abused. So we're just going to screw this on. So I'll get all these screwed on the edges now. And when that's done, I'll jump back to you. Okay, so just screwing on my end borders. I've just clamped 2 of my levels to the top of my MDF board. That gives me a perfect flat edge to work to, so I can ensure that my edge banding is perfectly flush with my top. So just want to line up the edge of my miters exactly with the corners, which they are right there. And now I know that this piece is perfectly flush with this. So you can see you have a small little gap between the board and the 2x4 because it's round over edge, but it's such a small little thing, it doesn't actually cause any issues. So let's get a screw in that. Okay guys, there we go. Edge banding is on all the way around. Again, exactly the same as I did with the miter saw station. Just went across at an angle to make sure that everything is nice and flush the whole way across. And it is. And the slab is your reference surface, so the edge can be even just a little bit below the slab. That's perfectly fine. You're using construction lumber if you're building the same thing as I'm building. It's often not the same thickness. It's not consistent. It's twisted. It's everything else. So if your miters aren't perfect, don't beat yourself up over it. Again, this material is not the same thickness. there's a couple of mil in the difference between this board and this board. Same with the end boards. None of them are the same thickness. And yeah, like I say, some of them are twisted and stuff like that. So you might not get perfect pointers. These ones aren't too bad. I'm pretty happy with it. So just as it is, this is a great assembly table. It's nice and big, good and strong and sturdy, plenty of storage. But we're going to make it into an MFT table with a router and downdraft table. So on to the MFT section. Okay guys, so we are on to the MFT table build, and I want this to be the main focus of this video. So I went and I bought the UJK Parf guide system. So I didn't want to spend too much money on the table. I did spend a bit of money on this. It is an expensive bit of kit. I did agonize over whether or not to build my own jig, but I mean, this has to be accurate. And if your MFT table is not accurate, then it's no good. So I said, you know what? I'll spend the money. I'll get the Parf guide system, the actual jig. It's CNC. It's almost up to CNC level accuracy when you're finished and when you do it right. So again, 260 euros, it's a lot of money. This is the Parf guide system 2. There is another system, the number 1, that's 160 euros. That's a little bit cheaper. You get a little bit more with the second system. And the reason I opted for it was when I replace this table after you put multiple cuts through it, say in a year's time, I can build another one. I can build smaller tables. I'll always have the jig, and I can build as many MFT tables as I need to build. So that's why I got it. That's why I spent the money on it. So I'll show you exactly what's in it. I'll take you through it. Now I ordered as well some clamps and some Parf dogs, but I ordered 2 sets of large dogs. They sent me 2 large dogs, and I ordered 1 pair of smaller dogs, and they sent me 1 dog. So I have to get back onto Axminster and let them know that they left me 1 of these short and short 2 of these. These are supposed to be a pair, 2 pairs, and 1 pair. Instead it's 1 and 2 single. So a little bit of a mistake there. I'm sure they'll rectify that, no problem. So I'll have to email them. Now, I might not be able to demonstrate the table the way I wanted to demonstrate it today because I don't have all the parts, but we can make the MFT top. I can demonstrate how this Parf guide system works. Works on Pythagoras Theorem, so it's a right angle triangle. It's basic enough, but it's highly accurate. So let's have a look at what comes in the box. Well guys, very quickly I'll just give you a look what comes in the box when you buy the Parf guide system Mark II from UJK. So you get the actual jig itself. So this is for lining up all your holes and for drilling your 20mm bit. There's a 20mm, I suppose it's like a Forstner bit for all the world that goes down through this shaft. It's perfectly machined, so that ensures that you're keeping your hole perfectly perpendicular to the top, and it's exactly accurate to where it needs to be drilling. So that's the jig itself for lining up with your guide holes, and that's for drilling out for your dogs. Now, there's your pins. They sit down into either your ruler or into your jig to hold everything in place once you've drilled your guide holes. Again, I'll explain as I'm using. So you get 3 of those. That's slightly different from the older pins. They're actually nicer to hold now. You get the 3mm drill bit. Now the 3mm drill bit is now inside in this shaft. In the previous kit, it was just a drill bit on its own, and here are the guides for the 3mm drill bit, so they're slightly different as well, so that fits perfectly down inside in them. They have a bush on the end, which allows it to fit exactly into the ruler, and you have this one, is the same thing, except it has a longer bush for when the 2 rulers are overlapped. The longer bush can go through the 2 rulers, so nice and simple. Again, you'll see all this in operation if it's not making sense. Now, it will be by the end of this video. There is just a collar, stop collar, so you can put a depth stop on the drill bits. 2 dogs, so they fit down inside in your guide for when you're drilling out all your holes that align everything up with your holes for you. Again, this will be explained when I'm using it. There's the 2 rulers with the marks on them for where you need to drill your holes. Again, this system uses Pythagoras Theorem, which I'll explain to you as well when we go to drill out this MFT top. Then you also have just a little threaded bush that goes through the butt rulers when you need to hold them together in your triangle or pattern to mark everything out. So that's it. That's what comes with the Mark II guide system. Again, you're going to see me use this in the video now and explain how everything works. Now, what I also ordered as well in a separate packet from Axminster, which is these Axminster clamps that you can use with your MFT table. So I just got 2 of those to get me going. I also bought the UJK, this is the chamfering tool, so you stick that down in your 20mm hole, it fits perfectly. You can ream it out and you get a nice little chamfer on it. Again, it doesn't come with the kit. It's an extra 30 quid, which is quite pricey for what it is. But if you're doing a lot of these tables, I suppose it's good to invest in the kit now. We'll make a decision whether it's good for DIY people at the end of this video. But like I say, I wanted accuracy, so that's why I went for it. So yeah, there we go. Also the dogs. So these are the dogs themselves. So like I say, Actually, the 2 dogs are actually in the box, so nice. So I take it back, actually. You did actually send everything on to me. So there you go. I got the 2 large dogs. There's actually 2 in one box. I thought it was 1 in the box, so my mistake. I apologize. So there we go. There's the 2 of those, 2 pairs of the 50mm dogs, and then there's the 2 smaller dogs. So we'll be able to use our bench today in this video as well. Very, very nice. So that's everything I got. Let's get on and make an MFT top. Okay guys, let's crack on with this MFT table. Now, it works on Pythagoras Theorem, so let me just explain that very quickly. You'll all remember this from your school days. So in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the opposite 2 sides. That's what the theorem states. So very, very simply, this line here is your hypotenuse. It's opposite these 2 sides, so it'll be x squared plus y squared equals z squared. So x squared plus y squared equals z squared. And once that's true, you know you have an exact right angle triangle. So that can be any measurement. You can measure this, square it, measure this, square it, and the sum of the squares should, if it equals this, you know you're good with your triangle. Now the beauty of that is it gives us what's known as the 3, 4, 5 triangle. So we have 3, 4, and 5. Now these can be any units you want, millimeters, centimeters, inches, feet, miles, kilometers, whatever. You can take 3 units, 4 units, and 5 units. So 3 squared is 9, 4 squared is 16, that equals 25, and 5 squared is 25. So you can see, square these 2, it equals the sum of the square of this guy. And once that is true, you know that you have an exact right angle here. You have a right angle triangle. So that's how this system works. So instead of using a 3, 4, 5 triangle, this is going to be using the 6, 8, 10 triangle. So again, 6 6s 36, 8 8s are 64, that equals 100, and 10 10s is also equal to 100. So the 6, 8, 10 triangle also works. And like I say, you can use that in any metric you want, so millimeters, centimeters, meters, yards, feet, inches, miles, kilometers. It will be true of all of those. So that's how this system works, and that's how we know we have an exact right angle. So hopefully that makes sense. It's probably as clear as mud, but again, it's back to primary school or secondary school days or high school days in America. You would have learned Pythagoras Theorem, and that's what we're going to use here. So let's get on. Okay guys, now that Pythagoras Theorem is explained, a little bit of classroom work there, we can crack on and do this. So it comes with 2 rulers, and there are holes cut in these rulers at exactly 96 millimeters. So our units of measurement are going to be 96 mil. Now why 96 mil? I believe that's to work with all the festival equipment. I think that's why that is 96 millimeters, but it will work with anything. It's just going to give us a square series of perfectly square holes. So each unit is 96 millimeters, so we're going to be using the 6, 8, 10 triangle like I just explained. So we have 0 to 10 on each ruler. Now, I've just marked out a line in from my border, roughly square, so I have it up top, down the side, along here. So when you're drilling your top, just make sure that you're not drilling down into your frame anywhere. That's why I haven't put any cross pieces in yet. I'll put them in afterwards once I have my holes out. So my frame runs in. I need to be in 110 millimeters so I avoid my frame, but in order to keep my grid perfectly square, I have to come in 130 millimeters from the edge of my slab. Now, I didn't measure from the edge of my 4x2s because they're not perfect. I measured in from the edge of my actual slab. So I'm in 130 mil, and that's what's going to give me my pattern. So the first set of holes we want to drill, so I have my intersection here. I'm going to line up hole number 10. You can start with hole number 10 or hole number 0, whatever way you want to do it. And I'm going to drill my first hole using the guide jig. So we have the guides for the drill bit. My 3mm bit is in my drill. Now ordinarily you would clamp these in place. I haven't got a clamps that are going to go in and clamp onto that, so I'm just going to drill my first hole as accurately as I can, and I'm going to put a pin down there then I'm going to drill my last hole and get a pin in there. That'll hold my ruler nice and perfectly aligned, and then I can drill the rest of the holes. So let's get on and do that. That's the first step we need to do. So just need to make sure that these little bushes are perfectly sat down into the ruler, that they are perfectly flush. Just check that and we can drill away. So let's do that. So this is where my first hole is going to be. Just like that. So now I should be able to put a pin exactly in there. So these pins again, the pin is exactly 3mm and it has a little bush on the end of it which sits in the ruler and aligns everything perfectly. So we want to make sure that that's perfectly flush. Now let me give you a close-up of that so we can explain what we're doing. Okay, so there you go. You can see where I drilled the first hole. You can see there's my pin hole, my 3mm hole. There's the little bush on the end of this guy. So when you're drilling, make sure that he is perfectly in there and perfectly flush. We want to be as accurate as we can, so we'll take our time with this. Once the hole is drilled, I have a little bush around my 3mm pin. My 3mm pin sits in the middle of my ruler, and that sits perfectly flush. We have to make sure that that bush is perfectly seated so that the ruler is held accurately. Now, the biggest difference between system number 1 and system number 2 is the fact that these bushes exist. There's a guide that comes with the first rulers and they have a 3mm hole, so the drill bit actually touches the ruler. So over time, obviously you will wear that out. And so the idea being with this is that the drill bit stays in the bush, never touches the ruler, so the system remains accurate no matter how many times you use it. You're not going to get wear on the jig system itself. So that's it. So now I'm going to go down to the end, drill my next hole, and then I can pin my ruler with 2 pins, and that should hold everything accurately for me, and I can drill the rest of my holes. Okay, down to hole 0, and I have this lined up exactly where I want it to be, so I'm going to just hold that in place. This pin is in place holding that, so we're good to go. Line up my jig. Just drill my hole. Get my next pin. Make sure that's perfect. Now that's my ruler is held between the 2 pins, so that can't actually go anywhere. So I can drill out the rest of these holes now, and I should be good. So I'm going to drill it at 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These holes also have 32 and 48. I'll explain that in a little while. Don't worry about that for now. We're just concerned with 0 to 10. So let's get these drilled. Again, making sure we're perfectly seated each time. Accuracy is key here. Okay, so there's our first row of holes. Now I can pull these pins, drop them back into 2 holes and move this ruler on down and keep on going. So I'm going to go a little bit further, and once I have that done, then I'll get back to you. So it's only a case of me pull this pin, push my ruler on down. I can line up 2 holes then again. So let's say here, line that up perfectly and line up this hole perfectly. And then I can keep drilling at my intervals. So I know that's a perfect straight line now that I can continue on down with. So that's what I'm going to do. I'm just going to drill a few more holes this way, and then we line up for a right angle triangle. Okay, so now I have a perfectly straight run of holes across the bottom. Now I need to establish a perfectly right angle set of holes up this side of the table, and that's where these jigs come in, and that's where we're going to make our 6, 8, 10 triangle. So this is what we do. Take our first ruler, our very first hole. I'm going to stick that in number 0, so hole number 0 on the ruler. Then we're going to take our second ruler, and this is the guide bush with the longer bushing on it. That goes through 2 rulers. So what we want to do is line up number 10 on this ruler with number 8 on this ruler. So if you can see now, we have 8, 10. Now we want to establish number 6. So we count out 6 holes. So 1, 2, 3, 4, 5, 6. I take number 0, get that onto hole 6, line that up perfectly, get that to sit in there. Now that's in, that pin is in. Now I've just completed a perfect right angle triangle. So now I know that this ruler running up here is exactly at right angles to this set of holes. So I can now proceed to drill my holes up this side. Let me get you a close up of that. Okay, so here's the intersection of our 2 rulers. You can see this ruler is at number 10, this ruler is at number 8. So that's our 8 side. This is our hypotenuse, so that's going to be 10. So we'll just make sure that they are gone together exactly. And again, there's a larger bush on this guide that goes through 2 rulers and holds them perfectly in place. So there's no movement on that whatsoever. It's perfectly machined. So measurement of 8, measurement of 10. Let's have a look down this end. Okay, so looking down this end then, you can see we have, like I said, 8 here, 10 here and 6 across here. We have our pins in place and that's held, so we counted out 6 marks, 1, 2, 3, 4, 5, 6, put a pin in that. So you can see now we have our 6, 8, 10 triangle. 6 6 is 36, 8 8, 64. Add them together, you get 100, and 10 10s are also 100. So we know that our Pythagoras Theorem is right, so that we can be 100% certain that that is exactly to the whatever nth degree, exactly 90 degrees, exactly right angles. So now I can drill a row of holes straight up here, which I will now know that they are perfectly at a right angle to this row of holes. Then I can reverse my triangle and drill a row of holes that way. That will make sure that those row of holes down this end are perfectly parallel to this row of holes. And then we can just link them all up and drill on out. So let's do that. So the first thing I want to do is drill this hole here where this is and put a pin in this, and then I can drill this row of holes. So while our guide bush is in place, I'm going to drill this. There we go. Now I can remove that ruler, put a pin in there, make sure it sits exactly, and now I can drill this row of holes. So I get on and drill this row of holes, and then I'll show you up here. Okay guys, next triangle is laid out. So we had our row of holes, a perfect straight line down there. We set up our triangle, we got a perfect right angle to these holes heading up this way. Now we can do the same, we can just rebuild this 6, 8, 10 triangle, and it'll give me a row of holes heading this way, which are a perfect right angle to this row of holes, which means this row will be perfectly parallel to this row and everything will be square. So that's the whole point. It's a really simple system to use. It's really nicely and precisely engineered. I have to say I really like using it. It's extremely easy. I know it's a bit on the expensive side, but when you see how quick and easy it is to drill out an MFT table, yeah, maybe it's worth a few pounds, especially if you're going to have a lot of sacrificial tops and you want to keep making MFT tables. If you're a professional user, a cabinet maker, or whatever like that, and you go through a lot of MFT sacrificial tops and you want to build one yourself each time, then it will start to pay for itself. But yeah, it's nice and handy, nice and easy to use. So let's get on. I'm going to drill this row of holes down here now, and then I can link up all my holes. So I'll get on and do this. You guys don't need to watch me drill any more holes. You get the idea of how this works now. So when it comes to drilling out the 20mm holes, then I'll show you how the jig works. Okay guys, so a slight little issue. You know, I like to show mistakes as I go through them, or anything that I find that goes wrong, just to help you guys out. So getting to the end of my hole. So you remember, I drilled a series of holes across the bottom, make sure they were perfectly in line. We built our triangle, made sure that this row of holes was perfectly at 90 degrees. So this set of holes, we did the same on this set of holes. And then we used our ruler to drill down this set of holes, assuming that it would be perfectly parallel to this set of holes. It should be in theory. But by the time I got to the end, so I'm about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I drilled 17 holes because my router table is going to start from there. There's a slight discrepancy. So this row of holes should be perfectly parallel to this row of holes, which means I should be able to put a pin in hole 0 here and a pin in hole 10 there on the opposite hole, but it doesn't quite fit. It's just a mil off. So there was about a millimeter of drift by the time I got to the end, which is strange because I used the pins to keep these holes perfectly in line and those holes perfectly in line. So something's gone wrong somewhere. So in order to drill the holes, I can't now put a pin here and a pin here and just drill those holes. I'm going to build my triangle off the bottom row of holes for every single row that's going to go up the table now. So I'll get you a close up and just show you exactly what I mean. And that should ensure that everything's at perfect right angles. And my top holes at the end will be slightly off, but I should be able to correct that with the larger jig because I've made sure that all the 9 holes up to the 10th hole are perfect. So a little issue there. Let me give you a look and I'll show you how far it's off. Okay, so there's hole number 10. So you can see it's just the tiniest bit off center. That should be bang on 10 if everything is exactly accurate. And I should be able to put my pin in there and it should sit flat with it doesn't. So it's about, I'd say it's just about a millimeter or just under a millimeter out, which is very strange considering I lined up all these holes with the jigs on both sides and ensured that I was coming out at perfect 90 degrees. I have a slight just under a millimeter off here. So like I say, I have to go through each row of holes now using the triangle. So you can see it's slightly off. So you can see what I'm talking about now. I have a tiny little bit off on the holes out. Now, when I put the rulers across these set of holes, perfect, perfect, perfect. Out to about hole 4, then it starts to shift the tiniest bit, which is very strange because if I put the ruler Along the bottom, all those holes line up perfectly as I drill them out, and the same on the top, so I recheck that. So I'm just going to build my triangle the whole way back for every single row of holes, rather than taking it for 100% certain that I can just put a ruler between here and those holes are perfectly aligned. They do seem to be perfectly in line. It's just the last holes have drifted in by just under 1 millimeter. Now, I'm not sure whether it's the jig, whether it's me, whether at each hole I drilled, was there a tiny error, and did that error compound 17 times to give me that just under 1 millimeter out. So it'd be a very tiny error for each hole. But like I say, the more holes you continue on with, the more that's going to compound. So yeah, so now what's going to have to happen, like I said, is I'm going to build that triangle the whole way back to ensure that every single one of these rows are absolutely perfect. Then when I'm drilling my larger holes, it's only going to be the last 5 holes on my top row that are slightly out, but I should be able to use this larger jig off the correct holes to drill that big 20mm hole exactly where it needs to be. So I can hold this jig in place with the correct holes, and that should account for my little bit of 1 millimeter that's off. So that should happen. So I'll get on and drill the rest of this. I'm going to keep, like I say, building my triangle the whole way along to make sure that these rows are perfect. And we'll try and address that discrepancy. So I just said I'd show you that, just something to watch out for. Check, and recheck with all these things, I suppose, is the good rule of thumb. And yeah, so I don't know whether it's me or whether it's the jig, who knows. But like I say, after drilling 17 holes down, I'm just under 1 millimeter out at this end. So there you go. So just to really hammer this home, because I know I'm going to get some comments say I wasn't using the jig right or whatever. Here's my triangle built on the other side, so you can see pin fits perfectly here. The intersection is perfect. Another pin in there, absolutely perfect. So this row of holes is at a right angle. This row of holes is at a perfect right angle. So you'd imagine these two would run perfectly parallel, but that's not the case. Watch this. So if I swing this ruler around on row number 1, you can see 2 pins fit in absolutely perfectly. Now let's go to row 17. So when we go to row 17, put my pin in here. Get that to fit in perfectly, and hole number 10, it will not go down. So as I've shown you already, that's off. If I go back to row 16, drop the pin in, that's off, and that hop happens all the way back to row number 9. So whatever happened, it started to drift from here on out, or the intolerance, whatever the little discrepancy is, compounds as we're going along. So you really start to notice it from hole number 9 on. The pin does not fit. So this row of holes and this row of holes are not parallel, even though it says that it's at perfect right angles with the jig. Okay, so now we're on to drilling out our main 20mm holes for our dogs. So we have all our guide holes in now and our grid pattern set up. So now we use the main jig, and that's how we get our 20mm holes. Now, the UJK Parf guide system MK2 comes with the vacuum attachment as part of the pack, so I've clipped that on. That'll be handy because when you're drilling MDF, you don't want to be breathing that stuff, and this will just keep it clear for me. So this has 3 pin holes in it, here, here, and here. You line them up with your holes. Just drop your pin in, just like that, and these 3 pins should fit perfectly. And they do, so that's perfect. Now, that puts me perfectly in line with my hole with this collar, so I'll be putting that through it with my stop block. That will allow me to drill that hole, and I will move my jig along like that. What that enables you to do is you can drill every second hole that way, and once you have all them holes drilled, then you can use these dogs in the big holes, swap your drill bit from this side to this side, and that gets all the holes that are left in between. So that's how it works. It's nice and simple. I'll show you it in operation rather than keep on talking. But I know my bottom row of holes are my reference holes, so I'm going to drill them first, and then I'm going to work my way this way up the table, because I know that these row of holes are perfectly right angles to this, because I built, like I said, my triangle the whole way along to drill these rows of holes, so that I can guarantee that they are accurate. So I know my last holes are slightly off, so what I'll do then is use this jig in place, pinned up the table from hole 9 to 17, and then use this bit down through this jig to get those holes perfect. So that little hole will not line up perfectly with those holes. I know it won't, but the jig should hold this bit in place so that it will adjust my 20mm hole exactly to where it needs to be. So that's the plan. I'll show you that when we get down there. I'm just going to start drilling this now and you guys can see it in operation. Okay, we're all set up. I have my vacuum attached. I have my stop collar set on my bit, so my bit is just sitting on top of the table now. That's set to just over 25mm, just over an inch, because my top is just over an inch thick. And now I'm going to put on my drill. Now these are made to work with a quick release drill. I don't have one of those. I could use my impact driver to just click this on and click it off every single time, but yeah, we'll just use this instead. So I have my 3 pins are perfectly in, they're bedded in, sitting in exactly where they need to be. The jig is in, so I'm just going to take my time with this and be as accurate as I can. So let's get the vacuum on and start drilling holes. And that should have given me now a perfect hole exactly where it needs to be. And that's nice and clean cut. I'll just give you a quick look and then I'm going to crack on and drill the rest of them. So there you can see we have a nice perfectly cut hole exactly where it needs to be. So we move on and drill out the rest of these. Okay guys, the hole drilling is going great. The jig works fantastic, which is good. Like I say, the vacuum system is great and the impact driver does the job. So perfect. Now I just want to address these holes that I have here from 9 to 17 that I know are slightly off. So I'm going to do that now before I continue any further. So just to show you, even with this jig, that these holes are off, so I can match up my holes. Let's see, that's hole 10 there. So I'll drop my pin in here, fits perfectly. My next pin here, let's get that in, fits in absolutely perfectly, but you can see this one will not go into that hole. So there is a discrepancy. Even this jig confirms it. Again, how it happened, I'm not quite sure. There must be a little discrepancy in one of those rulers that when you keep using the ruler straight along, it compounds, like I said, as it goes along. But that just proves it again. Look, my last hole, that pin does not fit in. Now, so what I want to do is, I know my holes running this way are good. I've proved that using the jig. So I'm going to use the 2 preceding holes and I'm going to drop my pins in and then we shall correct the discrepancy. And I'll give you a close-up of this now in 1 second. So get that pin in there. I know that hole is good and I also know that this hole is good. So we'll just drop in there. There we go. So those 2 pins are in now. They're seated correctly. My jig is perfectly aligned, and let me get you a close-up of the drill bit and you can see just how much it's off. It's only a fraction. Okay guys, this is quite a tricky shot to get, but I'm holding the camera in hand, so just to show you, there is my center point coming down on my bit and it's just off center of that hole. So there you go. So I'm going to use this jig now to correct that, and hopefully the drill bit will go straight down and it can't get pulled over into that hole because of the collar above. It should keep everything perfectly aligned. So that's how I'm going to correct these holes. So there you go. You can see it's only a fraction off, but that's enough for it to be off. So yeah, there you go. Okay guys, I have most of the holes drilled out now. What's left after that is all the in-between holes, and once you get to that stage you can no longer use the pins because you've nowhere to put 2 pins to hold the jig. So you have to start using the dogs now in the larger holes. And what I've done was I swapped the bit from this hole, or from this bushing collar, to this one, and now we're going to use these dogs in the holes that we've drilled to get the in-between holes. So let me just give you a close-up to show you what I mean, and I'll get on, finish off the drilling. Okay, so here's a quick close-up. So like I said, I've moved the drill bit from this collar to this collar. Now you can see that I have in-between holes and I can't put my pins in large holes. That doesn't work. So what you do, like I said, is swap the bit over. If I line the tip of the bit now with that hole and drop that down, you can see now my dogs click in there absolutely perfectly. So I have to say I'm really impressed with the jig itself. This is machined spot on. Everything fits exactly with this. My biggest concern is maybe the rulers. one of them might be slightly off, but I'll have to get a good vernier calipers to check that. But no complaints with the jig. Jig is working perfect and seems to be bang on. It has hit every single hole, bar the ones that were out, absolutely perfectly. So this is what I have to do now. So now you can see that puts me over this hole and holds everything nicely in place, which is pretty good. Okay guys, I have all the holes drilled. Now I'm just chamfering all the holes with the little chamfer tool. And this works really easy. You just pop it in the hole, it has a little blade on it. And you just twist it until it bottoms out. And move on to the next hole. Nice and easy. Very, very quick. It's a handy little tool, albeit 35 euros for this tool, which is quite expensive for what it is, but it does a right good job, gives you a perfect chamfer. And it's quick and easy. That's all the hole is done there now. So that's more or less the top almost finished. Just got to clean it up. Okay guys, the MFT top is almost complete now, more or less. So all the holes are in, everything is chamfered. So the dogs then sit in nicely. So the UJK dogs, nice tight seal. They have a little ring on them and that ring sits down into the chamfer. So that sits perfectly flush. Now, I had intended on doing how to use an MFT table in this build, but because I ran into problems with the UJK system, this video turned into a different video than I intended to make. So just a quick idea what you can do with it. So if you wanted to get perfect 90-degree cuts, I can put my piece up against that, just like that, and then I can put my track against these two dogs. That gives me a perfect 90-degree cut. If I wanted to do 45, I just come at the angle from that dog to here. That gives you a perfect 45-degree cut, and you have multiple other angles in between. You can also put clamps down through your table. You can clamp your workpiece, things like that. There's multiple jigs, multiple other things you use with this table. So when you're assembling carcasses and stuff, you can get perfect right angles. It can hold everything together for you. There's a heap of stuff you can do with an MFT table, which I'm going to do a separate video on. All the things you can do, and I'm going to build multiple jigs for use with this table as well. So that'll be a different video. Like I say, this video is going to get a bit long now, so we'll just rock on. So that's kind of it for the MFT top then guys. The grid pattern is in. Now I should just say you do not have to put in all these holes. You can do 2 rows at the bottom, 2 rows at the top, 2 rows either side, and then you can split maybe a section of 2 rows, a third in, a third away in. That's all the holes you need to do, everything that you need to do. I drilled all the holes in the grid for the simple reason I'm going to turn part of this table now into a downdraft table. So I'm going to double up these holes for use with dogs and the various jigs that you can do with an MFT table. I'm also going to build a downdraft table underneath a section of these holes for sanding to put all the sawdust down through the table. So that's in an upcoming video. So that's why I drilled all the holes. Like I say, you guys don't have to. You can lay out your grid and you don't have to put in all these holes. So that's kind of all that needs to be said, I think, on the MFT top for where we are right now. Right guys, there we go. I think we'll leave it there for this part of the build. Like I said, I didn't intend on making this video. It's just that I ran into problems with the UJK Parf guide system. I wanted to show you that. I wanted to demonstrate that. I want to also demonstrate how it's used. So now the video is getting a bit long. So there's going to be multiple parts to this series, building this assembly table. So like I said, we have to add a downdraft table to it. I left this portion clear of holes because this is where my router table is going to be. So I'll be standing here using my router. So I have to put my saw tear or souter, router lift and fence is going to go here. So we're going to do all that. We're going to cut in T-tracks and all that good stuff. We're going to put in storage underneath, so we still have to do all that. So when we put the router tables in, we might even build a router cabinet to keep that router nice and quiet. A place to store all our bits, all the tracks and all the stuff for an MFT top is going to go underneath. And we'll also have a dust extractor that I'm going to put underneath here. I want to put power onto this bench as well, so we'll have sockets, somewhere to plug in all our leads that we need to use. So that's going to be all part of the upcoming build. But like I say, this video is getting a bit long now, so I think we'll leave this just for the frame and focusing on the MFT top and kind of doing a review and demonstration of the Parf guide system. So hopefully you've enjoyed that, guys. Hopefully you've got something out of it. The Parf guide system, I have to say, the jig for drilling is absolutely perfect. I'm a little bit skeptical on my ruler as the fact that I ended up with that kind of just under a mil out discrepancy down there. Like I say, it's a quite expensive system. It's 260 euros for the Mark II, and you would think that you're paying that 600 euros, not for necessarily for the materials, but for the accuracy, for the machine accuracy. That's where all the money should be going. And like I say, it's a little bit out, but I was able to claw back that discrepancy because the jig for drilling is actually seems to be perfectly spot on. So I was able to you know, sort out that hole down there. So now all my holes are actually perfect. I ended up with perfect holes, but my rulers, I am skeptical. So I'll get a good vernier, I'll check those holes, check all the measurements on that, and see if it is a problem with one of the rulers. So I'll let you know in an upcoming video what I found out about that. So that's it, guys. I'm rambling now. It's time for me to get out of here. This has kind of been a long build. It's happened over a couple of days, and yeah, that's kind of it for now. So that's part 1. Part 2, 3, 4, and 5 will be coming up on this multi-use table that we're building. So I'll see you next one, guys. Take it easy.